Hey guys, this is a demonstration video on how to make best use of the Iron Eagle tiny house trailers that we've produced using SketchUp. We worked directly with Iron Eagle to make sure that everything is bang on accurate, and we've bundled all 9 of their trailer lengths, ranging from 12 to 28 feet, into a single download that's available for free on our website. You'll find a link to it in the description, as well as an annotation and a card in the top right. Obviously, the better you are with SketchUp, the more progress you'll make with this, so it kind of goes hand in hand with our tutorial package, which you'll also find on our website. So without further ado, let's look at how the sunken floor and flange system is meant to accept a tiny house foundation. First, let's do a quick tour of the model. I'll point out that I've got things organized into layers, which should be pretty obvious the way that they're labeled, including these options. So the options are fender flashing, the galvanized pan, and the stabilizer jacks. Then you can also hide the axles and wheels, the entire frame. There's also a license plate just to demonstrate where it will go. You can hide all the lights and the tongue jack. One of the big things about the Iron Eagle design is the sunken floor cavity, which means there'll be no metal directly underneath the tiny house floor. We've already made real-life videos going over all the features of the design in detail, as well as a demonstration of the construction of a floor inside an Iron Eagle trailer. So I won't go over all that again. I'll focus more on the actual 3D modeling here. So since this is a 20-foot trailer, and that measurement is from the edges of the flanges, we can do a 12-foot piece of lumber, and then what will be slightly less than 8 feet, because we're working inside the floor cavity, to do our rim joists. So I'll start down here and make my first piece of lumber. So I'm going to use the rectangle tool, start drawing here, and let's go 1.5, comma 5.5, and then I'll use the push-pull, pull that out, and let's make that 12 feet. So this will be a 2x6, 12 foot long. I'm going to make that into a group, and I'm also going to give it a wood texture. Let's use this one. There we go. Now I'll just select it and copy move it down to the end here to make a second piece, and then use the push-pull tool to snap this into here. Now you'll notice that the trailer framing has holes pre-punched in the side, and those are meant to accept hardware that will support those rim joists. So I'll just quickly make some bolts here so that we can visually see how that will work. Alright, obviously this is a very simple representation of that hardware. You probably want washers or maybe even use carriage bolts or something, but at least we can see where they are. And now we can just copy this over to the other side. Now we'll want the regular joist, so I'll just make a copy of one of these guys, swing it out, move it into place, and adjust the length. And let's say we want 16 inch on center, so I'll move a copy out 16 inches times, let's go with 12, 13, 14, it's pretty close. So this way we can see if any of them interfere with the hardware, which I don't think they do, but that could be adjusted. So let's just get this last one. Let's make this last space a little bit bigger, something like that. So these joists would have to be supported by joist hangers connected to the rim joists. So let's see if we can just pop some in there. Go to the 3D warehouse, I'll search 2x6 hanger, and pick this one. Let's bring this in, and I'll see if I can pop these in quickly. So now we can see roughly how the hangers will sit, and we can see that this type of hanger would not fit on the end joists. So maybe a different type of hanger needs to be used. Or maybe we just need to move the joists out a bit so that this type of hanger can be made to fit. And maybe this will affect the order in which we assemble things. And what about the space between these two joists now? It's no longer 16 on center, so maybe we need to bump all the joists down to account for that. Identifying and solving little issues like this is exactly what makes modeling in high precision great. Every little detail can be worked out before ever picking up a tool. Another thing that could affect the layout of the floor joists is the subfloor sheathing. Now, it would be nice to just put a bunch of full sheets down, 8 foot by 4 foot, but the 100-inch width of the trailer is 8 foot 4, so one sheet won't quite span all the way across. You'll notice if you watched our building series that we actually staggered some sheets, but a better way to do it is to put the bottom plate for the wall framing down first, and then put the sheathing in between. So let's do that. Alright, there's a bottom plate in, and again I took the time to put in the bolts just for visual cue. But we actually used threaded rod and ran it all the way up and bolted it down on the top of the top plate. So there's definitely different methods that can be used, but it's just a way of highlighting the fact that there are also pre-drilled holes for whatever method you see fit to secure basically the wall framing to the trailer. So now that we've placed two 3.5-inch bottom plates, the distance between the two bottom plates is less than 8 feet. So a single sheet of plywood trimmed down a bit will span the whole gap. So we'll want to go 4 foot in from this edge for the other dimension. So I'll put a guide at 4 feet, and that'll be out there. So we can see that to get a joist directly under that joint, we'll need to adjust the joist. So before I start covering things up, I'm going to make a layer specifically for the floor framing, and then I'll make a new layer for the sheathing so that I can toggle between the two and edit them separately. For the sake of simplicity, I've put all of the wood I've made so far into one layer called floor framing, but as the model grows in complexity, I would probably want wall framing, maybe even back wall, side wall, and so on. But now I'm ready to work on the subfloor, so I'm going to use the rectangle tool and just draw in between from the inner edge of that framing over to here, and then let's say it's 3/4 inch, so I'll pull that up 3/4. Make it a group, go to materials, wood, plywood, and paint it on there. Now I'm going to copy as many sheets as I will need to cover the whole floor. So we can see that there is a little bit extra, so I'll just resize this one. Obviously there's also a bit of interference with the fenders, so I can just carve that out of these sheets. Now I'm going to grab all these sheets, put them on the subfloor layer, and then toggle them off. And since I've still got the guide that I originally used to make the first sheet, I know that that's where the first seam is going to land, and I can use that as a reference to adjust my framing so that there will be a joist under every seam. Alright, there we go. So I basically just deleted everything so that I could reduplicate from my nice point of origin at 16 on center. And if we toggle the subfloor back on, so let's look over this seam. If we toggle it off, you can see that there is a joist under there. And let's skip one, go down to here. There we go. So directly over top of this joist is the seam. So there we go. Now there's one other thing I want to go over. You've probably noticed that part of the subfloor sheets are sitting directly on top of the metal side extensions of the trailer, and that the top of the floor framing is level with that deck height. So in a particularly cold climate where all thermal bridging should be eliminated, we could simply use thicker framing here and raise the floor above this level. We're using 2x6s, but I'm going to scale these up to the size of 2x8s to demonstrate. So now we've got 2x8 framing, which is 1 3/4 inches taller. So I've bumped it down 1/4 inch, which there's space to do because the sunken space is 6 inches deep. And the result is that the top surface of the framing is now 1.5 inches above the deck. This means that we could put some 2x2s to essentially support the sheathing and still allow for lots of insulation to be snuck in around the perimeter to isolate the subfloor from the metal of the trailer. And to get support on the ends, we could simply shorten this rim joist by 1/2 inch and then turn this bottom plate into a 2x6. And in fact, we probably should do that around the whole perimeter so that this edge has full support as well. Now I haven't touched the subfloor layer, so it's still sitting down at the original height. So I'm going to bring that up and then I'll add a bit of transparency to it so that we can look and see exactly what's happening underneath. So now we can see that the subfloor is supported everywhere that it needs to be. There's no sort of flapping edge that's unsupported. Every seam is over a joist, and it's lifted up off of the trailer so that insulation can be tucked under there. And of course, some wood will always have to be in contact with metal when building a tiny house. But there's methods that can be used to mitigate that, such as sill sealer or sill gasket as we call it, to give a bit of a thermal break between the two materials. From here forward, I would recommend going over the model, touching up things, organizing things into layers, and just making sure everything is bang on precise. I noticed that little things like my bolts got off from some of the resizing and things that I've done, so it's always good after doing any adjustments to make sure that it hasn't affected anything else. I should of course mention that I'm not a professional builder and that you may notice flaws or room for improvement in the technique that I've shown here, and absolutely do whatever you think is best, but this is a demonstration on how to basically use this 3D resource to figure all that out and decide how you want to go about it. So to download these and for more information, including on how to get different widths, which you may need if you're going to do an overhang on your tiny house roof, just visit our website and you'll find everything there. Another thing that could affect the spacing of the joists is how the another thing